1. Today we are going to study chapter 4 of differential equation. I am following this textbook by Heritage Publication. Okay, now let's talk about higher order linear differential equations. Generally, if we want to write nth order linear differential equation, the form would be like this. So there is some coefficient p naught of x, and we have nth derivative, and the nth derivative will decrease by 1 in the successive steps, and at last we get p nth of x y is equals to qx, where these all coefficients are real valued continuous functions of x on the interval I, which says that x lies in between alpha and beta. So this is what the linear differential equation of nth linear differential equation looks like mathematically. If we talk about some of the properties of it, then to define the uniqueness and the existence of the solution of these kind of higher order linear differential equations, we can solve them is the same way that we used to do in the linear differential equations of second order. For example, first of all, we have to find out what is the characteristic equation of it, and then find the complementary solution, and then find the particular integral of the question. So to find the particular integral of the solution of the question, we need to follow either the method of undetermined coefficient or the method of variation of parameters as per the question that we have given. As we know that method of undetermined coefficient is quite restrictive, and it can be solved for some of the some exponential and some trigonometric functions, but variation of parameter can be hard to solve, but can be much more broader to solve some equations. Okay, now let's see how do we find the intervals of the solutions that are sure to exist. So first of all, these linear differential equation of higher order are said to have some solution in an open interval I, when the solution of it is such that we have x naught, we get a value x naught for which the x naught lies in the interval which was defined by alpha to beta. So if that happens, then we say that the solutions exist for this differential equation. Now for the interval, let's see the question number first. What does it say? The question number first is a third order linear differential equation with the cosine and sine functions. That means trigonometric coefficients. So first of all, I divide this whole differential equation by t, such that I get this, first of all, p naught of x to be 1. Then we get this standard form. Now for interval, to find the interval where the solution exists, we need to first specify for which these coefficients exist. So and then after find the intersection of these interval where these coefficient exist, and that intersection of the interval is said to be the overall interval of the differential equation. For example, we know that this coefficient right here exists when t is not equals to 0. Alright, then again the same thing with this and the same thing with this. So we can say that the differential equation as a whole exists, or the solution of the differential equation exists on the interval from minus infinity to plus infinity excluding 0. Similarly, we solve this equation. So in this way we find the interval where the solution exists.